ever imagine. Like losing an arm, but you can still feel it. It's a weird thing, right? It's called phantom limbs, and that's just like the tip of the iceberg, what we're going to talk about today.
Right.
So get ready to be, um, I guess, surprised is a good word about the brain.
Yeah, it is intriguing, isn't it?
Mm.
We're diving into these excerpts from Phantoms in the Brain, a book by V.S. Ramachandran. It's packed with all these case studies about people with, really unusual neurological conditions.
Yeah.
Our kind of mission with this deep dive is to figure out, like, how the brain actually forms our experience of the world
Okay.
and ourselves.
Cool. So let's, I guess, start with this idea of the Penfield homunculus. I mean, I don't even know if I'm pronouncing that right.
You got it.
It sounds like something out of like science fiction or something.
It does, doesn't it? Um, but picture this. Imagine like a map of your whole body projected onto the surface of your brain. That's basically what the Penfield homunculus is. Except it's like a distorted map, Some areas, like your lips and hands, they actually take up way more space on this map.
Yeah, that makes sense, right? I mean, we use our hands for so much, and like we use our lips for, talking and eating and like expressing ourselves. So that makes sense. But how does this idea relate to this phantom limb thing?
Well, think about the brain. It's really good at adapting, right?
Hmm.
After an amputation, the brain's sensory map can actually like reconfigure itself.
Oh, wow.
The area that, used to get signals from that limb, the missing limb, well, neighboring areas can kind of take over that space.
So like if you lose a hand, then like the face area might kind of like move into the hand's territory in the brain.
That's exactly it.
That's pretty wild.
And that can lead to those, well, really unusual sensations. Like you touch someone's face and they feel it in their phantom hand.
I mean, it really throws out the window this old idea that like the adult brain is, fixed, right? Doesn't change. This plasticity, this ability to adapt. I mean, this has huge implications for like stroke recovery, right?
Ooh,
Potentially.
huge. It opens up so many possibilities for the brain to rewire itself.
Yeah, yeah. So, speaking of phantom limbs, why is it that some people feel like their phantom limb is stuck in like a painful position?
Ah, yes. Well, Ramachandran, the author we're discussing, he has this theory, and it's called learned paralysis.
So is something to do with like the brain not getting feedback from the limb before before the amputation?
You're on the right track there. So if a limb is paralyzed, before it's removed, the brain keeps sending out these commands to move, right?
Right.
But it never gets any confirmation that the movement actually happened.
Oh, okay. So the brain's just like, well, I guess that arm doesn't move, and it's like learning to associate that limb with paralysis.
Right. And that association, it can stick around even after the limb is gone.
Wow. So what can you do about that?
Well, Ramachandran, he came up with this, it's a pretty clever therapy for this. He uses a mirror
A
box.
mirror box. How does that work?
It's surprisingly simple, actually. The patient, they put their real limb into one side of this box and their phantom limb into the other side.
Okay.
Then they look in the mirror, and what happens is it creates this illusion, right? Their phantom limb looks like it's moving along with their real limb.
Oh, so it's like you're giving the brain the visual feedback that it's been missing, right?
Exactly. And this visual trick, it can really help. It can reduce phantom pain, and it
Yeah.
can even help the phantom limb feel like it's, moving again. There's this one case, Philip, whose phantom arm was frozen in this really painful position.
Oh, wow.
And with
Yeah.
mirror box therapy, he was able to unfreeze it,
Hmm.
and the pain went away.
I mean, it's amazing, right? That vision can actually override how the brain like perceives its own body.
It really is. And it actually leads us to another really interesting phenomenon, blind sight.
Blind sight. What is that?
Well, the name kind of gives it away, but blind sight is the ability to react to things you see, even if you're not consciously aware of seeing them.
Wait, so like someone with damage to their visual cortex, a part of the brain that like processes sight, they can still like react to visual cues even though they can't see them.
Exactly. It's almost like they're seeing without seeing.
That doesn't even make sense. How is that possible?
It's because visual information travels through different pathways in the brain. You have the what pathway, which is all about conscious sight. That's the one that's damaged in blind sight. But then you have the how pathway, which helps us guide our actions based on what we see. And that pathway can still be working just fine.
So in blind sight, the how pathway is doing its thing even though the what pathway is like offline.
Precisely. It's a bit of a paradox, isn't it?
Yeah, it is. It's incredible. It's like there's this level of like processing going on, like below the surface, right? Like we're not even aware of it.
Exactly. It challenges our understanding of consciousness. There's this great case, Diane. She could accurately, put letters through a slot even though she couldn't consciously see it.
Whoa, that's wild.
Makes you think, doesn't it, about the relationship between our conscious and unconscious minds.
It does. It's like there's this whole hidden world of perception going on that we're not even aware of.
Indeed. And that actually brings us to Charles Bonnet syndrome, which is it's a condition where visually impaired people have really vivid hallucinations.
Hallucinations? Like what kind of hallucinations?
They see all sorts of things, faces, animals, objects, even like whole scenes. And it all seems very real to them, almost like too real, or sometimes they describe it as cartoon-like.
Yeah.
Ramachandran's idea is that the brain, because it's not getting enough real visual input, it starts to create its own images.
It's like it's trying to fill the void, right?
Precisely.
With its own creations.
Yeah.
It's kind of like how our brains, deal with blind spots.
Yeah.
It fills in the missing information.
Exactly. It's the same principle, just amplified in Charles Bonnet syndrome. It really shows how our brains are actively creating our reality, filling in gaps, making assumptions.
Yeah, it makes you wonder if we all perceive the world in the same way, or if we each have like our own, unique realities created by our own brains.
That is a very profound question. And speaking of different perceptions, let's delve into another condition, neglect.
Okay, neglect. What's that about?
It's a condition where people with damage to their right parietal lobe, so it's a part of the brain that's really important for spatial awareness, they basically ignore one side of their world. Usually it's the left side.
Oh, so they're like bumping into things on their left or only eating food like from the right side of their plate.
Exactly. It's almost like the half of the world doesn't even exist for them. And it's not that they can't see it, it's just that they don't pay attention to it.
So their brain has like created this blind spot for half of their visual field,
Yeah.
even though their eyes are fine.
Exactly. And there's this theory called the spotlight of attention theory. Basically, the right parietal lobe directs our attention to different parts of space, like a spotlight.
Oh, I see.
But when it's damaged, that spotlight gets stuck, it fixates on the right and ignores the left.
That's fascinating. It
Yeah.
shows how like complex our spatial awareness is, right?
yeah.
And how easily it can be, disrupted.
It is. There's this one case, Ellen, she would reach into a mirror, like trying to grab objects, because she thought the reflection was real.
Whoa, that's incredible.
It shows how connected our perception and our actions are.
Yeah. So speaking of like kind of perplexing behavior,
Yeah.
let's talk about anosognosia. I think I said that right.
You did.
Where patients deny that they're paralyzed.
Yeah.
And they come up with like these, bizarre explanations for why they can't move.
Right. It's a really, really puzzling condition. So they're paralyzed, but they're completely unaware of it.
Yeah, it's both like intriguing and a little bit, I don't know, unsettling.
It is. Imagine like someone insisting they're just tired or that they're choosing not to move, even though it's obvious that they can't physically move.
It's almost like their brain is creating this alternate reality
Oh.
where they're not paralyzed.
That's one way to think about it. Ramachandran suggests it might be due to like a disconnect between the two halves of the brain.
Oh, okay. So like the left hemisphere, the one that's like, good at language and conscious awareness, it might just be clueless about the paralysis.
Yeah, something like that.
While the right hemisphere, the one involved in spatial awareness and body image, it knows the truth,
Right.
but it can't like communicate it.
That's the idea. Ramachandran suggests it might be like, a larger division of labor between the hemispheres. The left side wants to create this consistent story, even if it means denying reality, and the right side is like the devil's advocate.
It's like this internal battle, right, between wanting to maintain this image of yourself and actually acknowledging like the truth.
It is, and that conflict might be what's driving those denials in anosognosia.
So, I mean, that's really wild to think about, that self-deception could actually be like rooted in the brain, right, in neurology. And it kind of brings us to another condition that really highlights how fragile our sense of self can be. Capgras delusion.
Right, Capgras delusion,
Ah.
where people believe that their loved ones have been replaced by imposters. And it's, incredibly distressing for everyone involved.
That's terrifying. Like it's like something out of a movie. What causes that?
The really weird thing is these patients can still recognize the faces of their loved ones, but they don't believe it's really them.
So they see their face, but they don't feel that love or connection.
Right. And because that emotional response is missing, they come to the conclusion that the person in front of them must be an imposter.
It's like their brain is saying, well, this looks like my mom, but I don't feel anything, so it can't be her.
Exactly. And there's research using galvanic skin response, which measures like how much you sweat, as a way to track emotional arousal. And people with Capgras delusion, they don't show the typical increase in skin conductance when they see their loved ones.
So their brains aren't registering the, like, emotional significance of the faces they're seeing, even though they recognize them. I mean, it's amazing how emotion and perception are, like, so intertwined in the brain.
It really is. And this brings us to, well, I guess the final frontier of Ramachandran's exploration in this book,
Okay.
the role of the temporal lobe in mystical experiences, religious beliefs, and heightened emotional responses.
Oh, wow. Now we're getting into, like, really uncharted territory here. What's the connection between the temporal lobe and, these, like, profound experiences?
So the temporal lobe, it does a lot, right? It processes sensory information, memory, language, emotions. It's involved in shaping our sense of self, our spiritual beliefs, and even, our experience of the transcendent.
Okay, so are you saying that, like, our spiritual experiences actually have a neurological basis?
Well, think about temporal lobe epilepsy, for example.
Mm.
Seizures in this part of the brain can trigger really intense religious experiences, feelings of like cosmic unity, and really profound insights.
But are those people actually having, spiritual experiences, or is it just like a neurological, like, glitch?
That's a really complex question, but what we do know is that these experiences feel incredibly real to the people having them, and they often have a huge impact on their lives.
It's amazing to think that something as subjective as, like, a spiritual experience could actually be linked to, activity in a specific part of the brain.
It is. And Ramachandran, he suggests that the temporal lobe might be involved in amplifying the salience and the meaning of certain experiences, making them feel really profound and significant.
So, like, the same mechanisms that give us our sense of self and our connection to the world could also be responsible for our, like, spiritual yearnings and experiences of, I don't know, the divine.
It's definitely a fascinating possibility.
This deep dive has been um, incredibly illuminating. It's made me realize how much we still don't know about the brain.
It's a vast and mysterious organ.
So, you mentioned earlier that we'd wrap up with, like, a 10-point summary of the key takeaways from all this.
Yes, absolutely. Let's distill the essence of what we've learned about the brain today.
Okay, fantastic. Take it away.
Okay, so are you ready for these 10, like, mind-blowing takeaways about the brain?
Yeah, hit me with them. What have we got?
All right, first up, the brain's plasticity. It's like this incredible ability to reorganize itself, after an injury or even just like changes in our life.
Yeah, that's a big deal, right? For treating neurological conditions, it means there's hope for, like, recovery and adapting. So what's next?
Number two, the Penfield homunculus. Remember that weird distorted map of our body in the brain? It shows us that certain areas like, our hands and lips, they take up a lot of space, way more than other parts of the body.
Right, right. It shows how our brains prioritize, like, sensory input, I guess, based on how much we use those body parts. Pretty cool. What else is on the list?
Okay, takeaway number three, phantom limb pain. Often it comes from this thing called learned paralysis. The brain basically learns to associate that missing limb with not being able to move.
Oh, right, right. That's why some people feel like their phantom limb is, like, stuck, right,
Yeah.
in a painful position. Okay, that makes sense. Give me number 4.
All right, number four is all about the genius of mirror box therapy. It's that thing where you trick the brain by giving it visual feedback. So the brain starts to think the phantom limb is moving, which can really help with pain and give people back a sense of control.
Yeah, it's amazing how, like, just seeing something can change how we feel. Okay, what's next? What other, like, mind-bending things have we learned?
Number five, we've got blind sight. This one's like a real head scratcher.
Yeah.
It shows that we can actually process visual information even if we're not consciously aware of it.
I still can't wrap my head around that. Even with damage to, like, the visual cortex, the brain can still react to stuff even though the person's not, like, seeing it.
Yeah.
Wild. Okay, what's number 6?
Okay, number six, Charles Bonnet syndrome. Remember, it's when people who are visually impaired start having like super vivid hallucinations.
Oh, yeah, right.
It shows us that the brain, when it's not getting enough input from the outside world, it kind of starts to entertain itself.
Makes sense. Okay, give me number 7.
Number seven is neglect. You know, when people ignore one side of their world, it
Uh-huh.
really highlights how important the right parietal lobe is for our spatial awareness.
Yeah, it's kind of scary, right? How easily our like perception of space can be messed up.
Yeah.
Okay, what else is there?
Number 8, anosognosia. Remember, it's the denial of paralysis.
Right.
It really makes you think about self-awareness and how the brain sometimes just wants to create a story that makes sense, even if it means, ignoring reality.
Yeah, it's humbling, right? To think that our perception of ourselves isn't always accurate. What's next?
Okay, number 9, capgras delusion. That's the one where people believe their loved ones are imposters.
Yeah.
It highlights this really interesting disconnect between how our brains recognize faces and how we process emotions.
Right. It's not just about seeing the face, it's about feeling that connection, that emotional bond. All right, drum roll, please. What's the final takeaway?
And finally, number 10, the temporal lobe. It seems to be a key player in, mystical experiences, religious beliefs, even just really strong emotional responses. It makes you wonder about, the neurological basis of spirituality.
Yeah, that's deep stuff.
Yeah.
Okay, so we've covered a lot of ground today. Learned about the brain's like incredible abilities and also some of its really strange quirks.
It really is an amazing organ full of mystery.
I'm curious, was there like a particular case or I don't know, concept that really stood out to you?
I find blind sight really fascinating. The whole idea that we can process information and even act on it without even knowing it, it's just wild.
Yeah, it's a total mind bender. I think for me it's the Capgras delusion
Hmm.
that someone could like recognize their loved one's face but not feel anything,
Mm.
no emotional connection. It's just heartbreaking.
It is. It really shows how complex our brains are and how when things go wrong, it can really change our experience of reality.
Like each case study is like a piece of a puzzle, right?
Yeah.
Helping us understand how the brain creates our reality.
Exactly. And who knows what other amazing discoveries are waiting for us as we keep, digging deeper into these mysteries.
Well, before we wrap up, I think there's one more thing from Ramachandran's book that we haven't talked about yet. He talked about humor and tickling,
Oh,
right?
that's right. We haven't touched on those yet.
Yeah, let's go back to that. Why do we find certain things funny? And what's the point of laughter? From an evolutionary perspective.
Well, Ramachandran thinks that laughter might be a kind of social signal. Like it tells other people that something that seemed threatening is actually harmless. Think about our ancestors, right? They're like in the bushes and they hear a rustle.
Could be a predator, right?
Exactly. Heart-stopping moment. But then what if it turns out to just be the wind? Or like a harmless little animal?
Oh, okay.
Laughter helps to diffuse the tension. It lets everyone know that there's no real danger.
It's like a collective phew expressed through laughter.
Yeah, that's a good way to put it. And that also explains why we often laugh when we're surprised or relieved, like that nervous laughter you get in awkward situations.
Right, right. Like it's like a leftover from our ancestors, a survival mechanism. Fascinating. But what about the brain? Like what's happening in our brains when we laugh?
Well, it involves the limbic system, which is all about emotions,
Right.
and also the frontal lobes, which are the thinking part of our brain.
So it's not just an like automatic response.
Right.
It's more complex than that.
Exactly. And while we're on the topic of laughter, we can't forget about tickling.
Oh yeah, tickling. Why do we like lose it when we get tickled, even when we try so hard not to laugh?
Ramachandran thinks that tickling might use some of the same brain pathways as humor. It triggers this response that's both threatening and playful.
To like a fake attack, right?
Yeah.
Our brain knows it's not real, but our body still reacts.
Yeah, it's like a playful kind of aggression. And it might actually help with, social bonding, especially between parents and children.
Right, like building trust and connection through touch.
Exactly. And there are parts of the brain involved in this too, like the insular cortex, which processes touch, and the cingulate gyrus, which is involved in emotions and social behavior.
So tickling isn't just about the feeling on our skin, it's about all these complex things happening in the brain.
Right. And speaking of the connection between mind and body, Ramachandran also talks about pseudocyesis.
Pseudocyesis, what's that?
It's also known as phantom pregnancy.
Phantom pregnancy. That sounds like something out of like a really old book.
It does, doesn't it? But it's real. It's rare, but it happens. Women with pseudocyesis experience all the symptoms of pregnancy missed periods, bigger breasts, their belly swells up, they even have labor pains, but they're not actually pregnant.
Wow. So their bodies are reacting as if they were pregnant, even though there's no baby.
Exactly. It's a really powerful example of how our mental state can influence our physical state.
That's incredible and kind of scary too.
Ramachandran thinks that, if a woman really wants to have a child and she's under a lot of stress, maybe there's some cultural pressure too, it can trigger these hormonal changes in the brain that basically mimic pregnancy.
So the brain is telling the body that it's pregnant, even though it's not. I mean, what are the implications of that for, treating diseases and just like being healthy?
It's a huge area for exploration, this whole mind-body medicine thing. Maybe we can harness the power of the mind to help people heal.
It's like there's so much potential there.
There is. And Ramachandran even talks about how hypnotic suggestion might be able to influence our body.
Really?
Yeah, like he talks about the possibility of using hypnosis to get rid of warts.
Wait, like make warts disappear.
That's the idea. He argues that if hypnosis can do that, why not other things? Maybe even like cancer.
That's a pretty bold statement.
It is. But it's important to keep an open mind. We might not understand how it works yet, but that doesn't mean it's impossible.
Right. We should be open to new possibilities, even if they sound, kind of out there.
Exactly. And that brings us to the last chapter of Ramachandran's book, where he talks about the big one, the self.
Ah, yes. The self. Philosophers have been trying to figure that one out for centuries. What does Ramachandran have to say about it?
Well, he admits that the self is a really tricky concept. It's hard to define, and it's even harder to pinpoint in the brain.
It's kind of like trying to grab onto smoke.
Yeah, that's a good analogy. But we all have this sense of self, right? This feeling of being like one unified, continuous person.
Yeah, it's the I that experiences things, makes choices, feels emotions.
Right. And Ramachandran suggests that this sense of self comes from the interaction of multiple brain systems all working together.
So it's not just one thing. It's more like a combination of different functions.
Exactly. He talks about three main components of the self. The first one is the embodied self.
Okay, the embodied self, what's that all about?
The embodied self is about our sense of having a body. It's rooted in how we perceive our limbs, our posture, our movements.
It's like that feeling of being grounded in our body.
Yeah, and it's constantly being updated by all the sensory information coming from our muscles, joints,
It's
skin.
not just a static image of our body. It's like a dynamic representation of us in motion.
Exactly. And this embodied self is essential for, interacting with the world, moving around, doing things.
Right? It's like the foundation of our physical being. Okay, so what about the second component,
The second one is the executive self.
the executive self?
This is all about our sense of agency, our ability to make choices and control our actions.
It's the I that decides what to do, like the
What?
captain of the ship,
Right, and it's closely tied to the prefrontal cortex, which is like the command center of our brain.
the CEO of the brain. Okay, and what's the third component?
The third component is the mnemonic self.
Mnemonic self.
This one is grounded in our memories, our personal history, our sense of who we are over time.
It's like the story we tell ourselves about ourselves.
Exactly. And it's crucial for our sense of identity, our connection to the past, and, even our hopes for the future.
It's like the thread that connects all our experiences. Okay. So Ramachandran is saying that these three things, the embodied self, the executive self, and the mnemonic self, they all work together to create this unique sense of being a person.
That's right. And when things go wrong in the brain, it can disrupt the sense of self. Like with anosognosia, where the embodied self is compromised, or Capgras delusion, where the emotional connection to the mnemonic self is broken.
It's like a glitch in the system.
It is. And by studying these conditions, we can learn so much about, the neural basis of the self, but also about consciousness, free will, what it means to be human.
It's like we're peering into the depths of our own minds, trying to figure out what makes us who we are.
Exactly. It's a journey that's both exciting and humbling because we're constantly realizing how much we still don't know.
This has been an incredible deep dive. We've gone from phantom limbs to the nature of self, and we've seen how amazing and sometimes how strange the brain can be.
It's been a fascinating exploration.
So before we wrap things up, should we leave our listeners with something to think about?
Definitely. Let's give them a final thought to ponder.
Wow, we've really been through a lot in this deep dive, haven't we? From like phantom limbs to, the self and everything in between. Ramachandran's book, Phantoms in the Brain, it's really given us a glimpse into how incredible and just strange the brain can be.
It really has. It's amazing how adaptable the brain is. And also how it can sometimes trick us, play tricks on us, and of course, how much it shapes our view of ourselves and the world around us.
Yeah, and we've met all these people, right, with these experiences that just like blow your mind. It makes you question, like, what is reality,
Yeah.
really? What is consciousness? What does it mean to be human?
Absolutely. I mean, think about phantom limbs or people denying that they're paralyzed, like an anosognosia. Each of these cases, they shed light on how this incredible organ works.
One thing that I keep coming back to is this connection between our minds and bodies. It's something that we don't always like think about consciously.
Yeah. Right, right. But it's so clear in Ramachandran's work. Like, remember Mary Knight experiencing a phantom pregnancy? Her desire to have a child, it actually manifested physically. It's like blurring the lines between what's real and what's not.
It's amazing. And it makes you think about, the potential for like using the mind to help heal the body.
Exactly, mind-body medicine. It's a really promising field.
This whole deep dive, it's given me such a sense of awe for the brain. It's so complex and adaptable.
It really is. But at the same time, it's humbling because we still have so much to learn. The brain is like the final frontier of science in a way.
And it's not just about neuroscience, right? It's about
Yeah,
bringing
yeah.
together all these different fields: psychology, philosophy, computer science, even art.
Yeah, we need all those perspectives to really understand something as complex as the human mind.
So to all our listeners out there, as we wrap up this deep dive into phantoms in the brain, we want to leave you with something to think about.
A final thought to ponder.
If our brains can create these incredibly real, incredibly convincing experiences, how do we know what's like truly real?
What parts of our world are actually out there and what parts are just, projections of our own minds?
It's a big question,
Huh.
and it's one that we hope you'll keep exploring. Thanks for joining us on this journey into the brain, and until next time, keep those synapses firing.